Assalamu alaikum warahmatullahi wabarakatuh. Sat Sri Akal, Namaste, and good afternoon, everyone who is joining me for this free for all mathematics class on Sunday, every Sunday at 1 o'clock. Today, my session or the topic of my today lesson is, as you can see on the screen, is solving the problems which involve any maximizing or minimizing or maximum and minimum perimeter or area. So I will explain you how we can find out or how we can uh, find out the value involving any kind of area or perimeters for finding any maximum area or the perimeter we need. I'll explain you one example and then we will do the calculation and it will make much easier for you to understand how we can calculate in our daily life. And I'm trying to use a daily life example so it makes much easier for everyone to understand what are we discussing and all the details. So remember in our last four sessions, we have been discussing, the rectangle, we have cylinders, take an example of cylinders, and we have discussed about the perimeters and the area, at what stage the perimeter can be a maximizing or maximum perimeter we can get, or at what stage we can get the maximum area from a certain perimeter. So if you please review before reviewing or watching this lesson, if you have any confusion, go back and watch my previous four lessons about this topic individually because I try to touch one small topic each day or each week, sorry, so that it make much easier for everyone to understand all these sessions and all these explanation. Because if you try to just watch one lesson and you don't have the background what we have been discussing in previous lessons, it becomes challenging. So every student who try to watch one particular lesson, if he or she sees there is a challenge or difficulty, yes, you can call me, you can contact me, but before doing that, I'll recommend strongly to go back to the previous lesson and then see and watch those lessons and get your base or root concept clear and then come to the same lesson. I'm confident that I tried my best to go as simple as I could to explain from the daily life. So today, as the topic is solving the problems involving maximum and minimum perimeter and area, as everyone knows, I always use this book as my guideline and I follow this book. If anyone is following my lessons, do not hesitate, use this Ontario curriculum lessons and this book, and it will be much easier for you to follow lesson by lesson. So I have an example, and once again, I'm going to explain that to solve a problem involving maximization or minimization, apply the principle covered in the previous four lessons regarding maximum and minimum perimeter, area, and volume. So as I mentioned earlier, if you have any difficulty in this today's lesson, first please go and review the previous four lessons addressing all these topics one by one, and then it makes much easier. But once I explain you even this particular problem or this question we are going to solve is still itself, it's very easy. The example I'm using that Mr. John purchased a 42 meter of a building material to create a boundary wall for his daughter's rectangular sandbox. He first created an outline of the sandbox on the ground using a 42-meter piece of string. What are the dimensions of the sandbox if it has to have a maximum area? So Mr. John trying to use that 42 meters of the boundary material he bought, and he wanted to make sure that he wanted to use the 42-meter of the fence or what are the siding he wanted to use, but he's planning and his wishes to get the maximum area. So now we are going to find out how he can set up his sides or length or width so that he can get maximum area from this particular 42 meter of perimeter. So we got the perimeter, but we need to find out from this perimeter how we can get the maximum area. So remember our four lesson previously where we explained that maximum area occurs in any particular shape, rectangular shape is when the rectangular is a square. So remember when we were discussing in lesson that the moment you keep reducing the rectangular shape towards square, you keep seeing that using the same perimeter, your area is increasing. So first it was rectangle with the same perimeter. You reduce the size and make it more square, square, square. And at a one stage, you got it exactly a square shape. And this is how you can find out with the same perimeter, which was previously in the shape of rectangle. Now it becomes the square. And now when you find out the length multiplied by width and get the area, you were noticing that the area got the maximum area. So each time you reduce, you can find out the area. But when the then square shape become exact square shape, the area will become a maximum area. So now in this particular case, we were given a 42 meter of perimeter, and we wanted to find out how this Mr. John can utilize this 42 meters and get a maximum area. So that means if we have to calculate a square shape, our length and width should be the same. So this is why I write down width and length should be same. And this is how we are going to find out. And the perimeter we are getting, that means we need to cut that 42 meter of string or whatever the material into 4 equal parts. So this is how the actual we got 42 divided by 4. And when we divide these numbers, actually we have 42 meters, that string. So when we divide, we got 10.5 meter. So that shows if we make that Mr. John make that sandbox, uh, those sides with 10.5 meter of each piece, and then make a sandbox, he will be using exactly 42 meter of his those drywall or those 2 by 4 2 by 6, whatever the wood he's using. He need to utilize 42 meter into 10.5 meter pieces, and then once he used this shape, then he can get exactly, once he got a square shape of 10.5 and 10.5, and this is 10.5 and this is 10.5. So that means his whole area will be the perimeter of 42 meter was used as to get a maximum area of the sandbox. So this is how in the daily life, once we are trying to find out how we can utilize this particular perimeter to get the maximum area, that's how we can calculate and find out. And in this particular case, we found out that Mr. John had purchased a 42 meter of the material, and he wanted to make a sandbox, and he wanted to make sure that he would cover a maximum area. So this is how he calculated. He utilized this guideline, and with perimeter divided by 4 equal parts, he found out that if he cut that string or whatever the material using into 10.5 meters, he would be able to make a square. His perimeter or use of that edges or the boundary, whatever he is going to use, will remain 42 meter, but he will get the maximum value of the square area from that particular cell. So that was today's topic. I hope it helped many of the individuals who are interested in taking advantage of this free for all mathematics classes. As I mentioned in my previous sessions as well, I have started posting these onto my YouTube channel. So please do look for mathematics for grade 9, searching might be my name as well. And once you see those channels, watch those channels, subscribe those channels, and share within your circle and with your family and friends, whoever is interested. And if you still have any questions, do not hesitate reaching out to me through WhatsApp or Facebook Messenger. WhatsApp, you can reach me at 416-571-1163. Because what if you watch those YouTube channels, which I have posted almost all of my channels, today's channel and the previous week, I will be posting later today, and then it will be up to date all of my those sessions. So do not hesitate watching those, and looking forward to see you next Sunday, and happy new year to everyone who is watching this today or at a later date. May God bless everyone that 2021 will become COVID free, and may God bless everyone with his non-stop rain of blessings and make us able to absorb every drop of his blessing in a positive way. Thanks and have a great day. See you next Sunday.